Central Processing Unit CPU. Selects and interprets program instructions and brain of a computer system. Performs all major calculations and comparisons. Activates and controls the operations of other units of a computer system. Two basic components are Control Unit CU and Arithmetic Logic Unit ALU. No other single component of a computer determines its overall performance as much as the CPU. CU, one of the two basic components of CPU, acts as the central nervous system of a computer system. Has some special purpose registers and a decoder to perform these activities. Arithmetic Logic Unit ALU. Arithmetic Logic, one of the two basic components of CPU. Actual execution of instructions takes place in ALU. Has some special purpose registers. Has necessary circuitry to carry out all the arithmetic and logic operations included in the CPU instruction set. What is instruction set? CPU has built-in ability to execute a particular set of machine instructions, called its instruction set. Most CPUs have 200 or more instructions such as add, subtract, compare, etc. in their instruction set. CPUs made by different manufacturers have different instruction sets. Manufacturers tend to group their CPUs into families having similar instruction sets. New CPU whose instruction set includes instruction set of its predecessor CPU is said to be backward compatible with its predecessor. What are registers? Special memory units, called registers, are used to hold information on a temporary basis as the instructions are interpreted and executed by the CPU. Registers are part of the CPU, not main memory of a computer. The length of a register, sometimes called its word size, equals the number of bits it can store. With all other parameters being the same, a CPU with 32-bit registers can process data twice larger than one with 16-bit registers. Function of commonly used registers. Memory address MAR. Holds address of the active memory location. Memory buffer MBR. Holds contents of the accessed read/written memory word. Program control PC. Holds address of the next instruction to be executed. Accumulator A. Holds data to be operated upon, intermediate results, and the results. Instruction I. Holds an instruction while it is being executed. Input/output I/O. Used to communicate with the I/O devices. Processor speed. Computer has a built-in system clock that emits millions of regularly spaced electric pulses per second known as clock cycles. It takes one cycle to perform a basic operation, such as moving a byte of data from one memory location to another. RISC-reduced instruction set computer. Mostly used in workstations. Small instruction set. Fixed length instructions. Reduced references to memory to retrieve operands. CISC complex instruction set computer. Mostly used in personal computers. Large instruction set. Variable length instructions. Variety of addressing modes. Complex and expensive to produce. EPIC explicitly parallel instruction computing. Mostly used in high-end servers and workstations. Allows software to communicate explicitly to the processor when operations are parallel. Uses tighter coupling between the compiler and the processor. Enables compiler to extract maximum parallelism in the original code and explicitly describe it to the processor. Multi-core processor. Mostly used in high-end servers and workstations. Processor chip has multiple. Cooler running, more energy. Efficient processing cores. Improve overall performance by handling more work in parallel. Can share architectural components, such as memory elements and memory management.